student, this is Dr. Rajneesh Kumar, Associate Professor in NIT Pharmacy Institute. So, I am here again in front of you with another lecture which is focused on Unit 4 of Pharmaceutical Organic Chemistry II. The subject code is BP 202T. So, students, in our previous lectures we have discussed about the carbonyl compounds, mainly aldehyde and ketones. So, we have discussed that nucleophilic addition reactions are the characteristic reaction, except that we have also discussed about the qualitative tests which we are used for the identification of aldehyde and ketones. Except nucleophilic addition reactions and the qualitative test, we also discuss about some name reaction as per the syllabus, that is Perkin reactions, that is aldol reaction, then cross aldol reactions is also being discussed. Then we have discussed about the Cannizzaro reactions and cross Cannizzaro reaction. So, all the reaction which I have mentioned are the examples of nucleophilic addition reaction. So, without wasting any time, I am just coming to the today's topic, that is Benzoin condensation and Perkin condensation reaction. So, first of all we will talk about the Benzoin condensation reaction. So, students, as I told you that nucleophilic addition reactions are the characteristics property or characteristic reaction given by the carbonyl compounds. So, benzoin condensation reaction is also you can say grouped in that particular class of the addition reaction. Okay. So, what is benzoin condensation reaction actually? So, as you can see in the reaction, we are taking an aromatic aldehyde and in the presence of cyanide, and you can see the ethanol and water, we are producing benzoin. So, benzoin condensation is an important reaction in which carbon-carbon bond is formed when two molecules of aldehyde, particularly benzaldehyde, reacts with each other to form a condensed product which is known as the benzoin. Okay. So, actually it is a condensation reaction which is taking place in between two molecules of the aromatic aldehyde, or you can say that in benzoin condensation reaction, two molecules of the aromatic aldehyde, particularly benzaldehyde, are you can say condensed together or added together in the presence of cyanide ion to give a product known as benzoin. Benzoin is what? This is alpha hydroxy ketone. Okay. So, this reaction is named of Friedrich Wöhler and Justus von Liebig in 1832. These are the scientists which actually gave this particular reactions. This reaction is catalyzed by the cyanide ion. So, the role of cyanide ion is very important. How? As I told you that this reaction is an example of the nucleophilic addition reaction. So, cyanide ion in this particular reaction it will act as a nucleophile. That nucleophile cyanide ion will attack on one of the benzaldehyde molecule in the first step. After that, when we will get the carbon ion as a result of the attack of nucleophile cyanide ion, then that particular carbon ion will be added to the second molecule of the benzaldehyde, and in the last we will get benzoin as a product. So, how it is taking place we just see. So, you can see there again, just focus on the reaction. We are taking two molecule of the benzaldehyde in the presence of cyanide ion which is acting as a nucleophile. We are getting benzoin, that is an example of the alpha hydroxy ketone. Okay. So, how the reaction is taking place? So, we can understand by its mechanism. So, in the first step, as you can see, nucleophilic addition of the cyanide ion occur with benzaldehyde to form a cyanohydrin. So, you can remember this step as a formation of cyanohydrin. Okay. You can just remember that in benzoin condensation reaction, in the first step cyanohydrin is being formed. How it is being formed? You can see. So, we are taking one molecule of benzaldehyde in the starting substrate, then you can see cyanide. Cyanide ion can come from the potassium cyanide or the hydrogen cyanide. So, that particular potassium cyanide and or the hydrogen cyanides can be acting as a precursor of the cyanide ion. Now, that cyanide ion will be acting as a nucleophile, and that nucleophile will be attacking on the this particular carbonyl carbon. How it is possible? Because if nucleophile will be attacking on a particular carbon, it should have at least positive charge. So, as you can see, there is a carbonyl group, oxygen is attached in the carbon. So, this oxygen is more electronegative, we all know that. So, electron is being pushed toward the oxygen. At that time, this oxygen became slightly positive charge and this carbon at that time carried slightly this oxygen became slightly negative charge and that particular carbon became slightly positive. Okay. So, when this carbon became positive charge, at that time that nucleophile will be attacking on this particular carbon. Okay. So, at that time you can see as electrons are moving towards the oxygen, that oxygen become negative charge and that cyanide is attached to the carbonyl carbon. So, in this next step, as you can see, the water molecule is there in the reaction mixture. So, this bond will be broken, negative charge will be going towards the oxygen of the water and this hydrogen is now free, will be attached to the negative charge oxygen. Okay. So, there is a removal of 1 mole of hydroxyl ion and we are getting cyanohydrin in a first step. So, again I am repeating that in the first step nucleophile cyanide ion will be attacking on the carbonyl carbon. How? Because that double bonded electrons will be moving toward the oxygen. In this process, this carbonyl carbon became positive charge and this oxygen became negative charge. At that time, this negative charge cyanide ion will be attacking on that particular positive charge carbon. A new bond will be formed in between this carbonyl carbon and the carbon of the cyanide ion. That is why I have told you in this previous slide that there is a formation of new carbon carbon bonds. Okay. In the next step, this particular bond will be broken. Okay. H plus will be removed from the water, that H plus will be moving toward that negative charge oxygen atom. Okay. And as a result, we are getting cyanohydrin. So, student, I am again repeating very important step. You can remember it this step as the formation of cyanohydrin in the benzoin condensation reaction step 1. Now, coming to the second part. Okay. So, in the second part, condensation reaction occur in between cyanohydrin and the second benzaldehyde. So, once the first step complete, the product of the first step, as you now know that cyanohydrin will be reacting with the second molecule of the benzaldehyde. How? You can see here. So, this is the cyanohydrin molecules. Okay. Basic medium is there, OH minus ions are there, hydroxyl ions are there. So, now you can see these electrons will be moving towards more electronegative nitrogen atom. In this particular process, this carbon become positive charge. When this carbon become positive charge, this bond will be broken and these electrons will be utilized to form a new bond in between this carbon and cyanide carbon. Okay. Hydrogen will be removed as a positive charge ion, that will be again added to the OH minus hydroxyl ions. Okay. So, 1 mole of the water will be removed and there is a formation of a double bond in between carbonyl carbon, as you can see, and the cyanide carbon. Okay. As you can see there this is a formation of new double bonds. Okay. In the next step, as you can see, nitrogen is carrying lone pair of electron. So, which is happening in the first step. So, now again these electrons will be moving towards again in between carbon and nitrogen. Okay. And this carbon, these double bonded carbons will be utilized to form in a new bond in between the carbonyl carbon of the second benzaldehyde and the carbon of the first benzaldehyde. So, as you can see, this carbon these electrons are being utilized to form a bond in between this carbon and this carbon. So, you can see this is the formation of new double bonds. Okay. Okay. So, again in the next step and because electrons are moving towards oxygen. Okay. So, this oxygen become negative charge. In the next step you can see this bond will be broken. Okay. Here this bond will be broken, H plus will be removed from the water molecule, that H plus will be added to that particular negative charge oxygen. So, we are getting this molecule in the next step. Again in the next step, in the presence of base or you can say hydroxyl ion, a new process is being going on. How? That bond is again will be broken, yes, this bond, and this H plus will be moving towards that hydroxyl ions. Again 1 mole of the water will be removed from the molecules, and you can see we are getting a molecule in which oxygen is carrying the negative charge. So, okay. So, this is the completion of the second step, in which the condensation reaction occur in between two or you can say in between the intermediate cyanohydrin, which is formed in the first step, and the second benzaldehyde. So, this is the cyanohydrin and this is the second benzaldehyde molecules. Both molecules are now being added by means of condensation reaction in the presence of base. Now, coming to the third step, that is rearrangement reactions, in which removal of the cyanide groups occur to produce the benzoin. So, now we are getting a molecule in the second step, okay, which is condensed product of the cyanohydrin and the benzaldehyde. Now, in the next step you can see oxygen is carrying negative charge, that negative charge or you can say lone pair of electrons now being utilized to form a new bond in between this oxygen and the carbon. Okay. At the same time, to balance the you can say valency of the carbon, these bond will be broken. So, Cn minus will be removed, Cn minus will be removed from the molecules, and a new bond in between oxygen and carbon is being formed. As you can see, this bond is formed. Okay. So, benzoin is formed in this particular step. So, rearrangements occur, okay, and we are getting benzoin, which is actually alpha hydroxy ketone. This is the alpha carbon, and you can see hydroxyl group is present on that particular alpha carbon, ketone is there. So, alpha hydroxy ketone is being formed, which is known as the benzoin in this particular benzoin condensation reaction. So, now this is very important reaction. Okay. So, we have also discussed about the aldol, cross aldol, Cannizzaro and cross Cannizzaro reaction. So, those reactions also belongs to the nucleophilic addition reactions. Okay. Those reactions also went on with the nucleophilic addition reaction, means nucleophile was attacking on the carbonyl carbon. You just see the previous lectures, you can better find a way to collaborate or to find a relation in between aldol, cross aldol, Cannizzaro, cross Cannizzaro and the benzoin condensation reaction. The same reaction mechanism will be followed by the each and every reaction. The only thing is the type of nucleophile will be different in each reaction. So, now coming to the scope, as I told you, this is a very important reaction. Benzoin condensation have a wide scope in organic chemistry as well as another branch of the chemistry, medicinal chemistry you can say. So, the reaction can be extended to aliphatic aldehydes with base catalysis in the presence of thiazolium salt. So, as I told you in the starting of the lecture that benzoin condensation basically belongs to the aromatic aldehydes, but that reaction can also be extended to the aliphatic aldehyde, but we have to change the reaction condition for that. Okay. We have to make change or you can say we have to introduce thiazolium salt as a catalyst to extend benzoin condensation for the aliphatic aldehydes. The analogous 1,4 addition of an aldehyde to an enone is called the Steter reaction. So, if 1,4 addition of an aldehyde to an enone, okay, here you can you have seen that the reaction or you condensation, you can say the condensation occur in between two benzaldehydes or two aromatic aldehydes. If we go for the 1,4 addition in between an aldehyde or and a ketone, then that reaction is known as the Steter reaction. In biochemistry, the coenzyme thiamine, very important molecule, you know that if you have studied the biochemistry. So, the coenzyme thiamine is responsible for the biosynthesis of acyloin like compounds utilize the benzoin addition. So, again acyloin is what? Acyloin is again alpha hydroxy ketone. Okay. So, biosynthesis of alpha hydroxy ketones like structure can also utilize benzoin condensation reactions for the synthesis of thiamine. Thiamine also contain a thiazolium moiety, which on deprotonation becomes a nucleophilic carbene. You know about the carbene. Okay. So, thiamine, I want to say that thiamine, which also contain a thiazolium moiety, if we go for the deprotonation of the thiamine, okay, that results in the nucleophilic carbene. Okay. The asymmetric version of this reaction has been performed by utilizing chiral thiazolium and triazolium salts. Triazolium salts were found to give greater enantiomeric access than the thiazolium salt. Okay. So, as we know that again this is very important points. How? Because in medicinal chemistry, okay, we need pure compounds. Pure compounds means enantiomeric pure compounds, okay, because two different enantiomer can have two different pharmacological activity. So, asymmetric synthesis is very important to get one of the enantiomer in pure form. Okay. So, when we can also apply asymmetric synthesis in case of benzoin condensation. Okay. How? We can utilize chiral thiazolium and triazolium salts. Triazolium salts were found to give greater enantiomer access than the thiazolium salts. So, there is a point which we must remember that triazolium salts are being preferred over the thiazolium salts, because by using triazolium salts we can get more enantiomer access, which is very useful for us. Now, come to the benzoin, which is being prepared in that particular reaction. So, benzoin is having very important because it is having lot of uses. Okay. So, few of the uses of benzoin is I have mentioned here. So, tincture of benzoin is made by using benzoin. Benzoin is used under adhesive bandage. Benzoin is applied on the skin to protect it from allergy. It is also used by athlete for toughening the skin. It can be used by orthopedists under the cast. Benzoin can also be applied skin fissures, fever blisters as an antiseptic. So, it is again used as antiseptic. Benzoin can also be used in alternative medicines. It is also being used for the treatment of asthma, bronchitis and common colds. Benzoin can also be used in military also to protect loss of skin. So, these are few examples by which we can see that how benzoin is very important for the pharmacological purpose. So, this is all about the benzoin. Now, the next reaction which I would like to discuss with you students, that is Perkin reaction. Okay. So, Perkin reaction is again a characteristic reaction given by the aldehyde and ketones, or you can say carbonyl compounds. It is also following the same reaction mechanism, nucleophilic addition reaction mechanism, but now the starting reagents are different, okay, and the catalyst is also different. You can say reaction conditions are also different in case of Perkin condensation reaction. So, what is Perkin condensation reaction? As you can see, this is the reaction which is being done in between aromatic aldehyde and acid anhydride in the presence of sodium acetate and base. Okay. So, aromatic aldehyde is reacted with acid anhydride in the presence of sodium salt, you can say sodium acetate and a base, for example, NaOH, and what we are getting? We are getting alpha beta unsaturated carboxylic acid, alpha beta unsaturated carboxylic acid, for example, cinnamic acid. Okay. Very important molecule cinnamic acid is. So, What is Perkin reaction is actually? The Perkin reaction is an organic reaction used to convert an aromatic aldehyde and an anhydride to alpha beta unsaturated carboxylic acid using sodium acetate, a base and an acid workup. The Perkin reaction is an organic reaction developed by Sir William Henry Perkins that is used to make cinnamic acid. So, this is the name of the scientist which discovered the Perkin reaction. Okay. He is responsible to for the preparation of cinnamic acid. So, again I just want to remember you that when aromatic aldehyde is reacting with the acid anhydride in the presence of sodium acetate or base like sodium hydroxide, we are getting alpha beta unsaturated acid as a result. So, now coming to the mechanism. So, this is the reaction which we have discussed. You can see when we are taking benzaldehyde as an aromatic aldehyde, when we are taking acetic anhydride as acid anhydride, we are taking sodium acetate, we are taking NaOH as a base, we are getting alpha beta unsaturated carboxylic acid. In that particular reaction, this is cinnamic acid. You can see alpha beta. So, there is a double bond or you can say unsaturation in between alpha carbon and the beta carbon. So, this is a alpha beta unsaturated carboxylic acid named cinnamic acid in this particular example. Now, coming to the mechanism of action of the Perkin reaction. So, you can see this is a benzaldehyde, example of the aromatic aldehyde. Now, we are taking acid anhydrides, in this particular case acetic anhydride is being taken. So, what is actually going on? So, in the presence of base, in the presence of base, one atom of the hydrogen is being abstracted from the acidic anhydride. So, you can say one hydrogen from that particular carbon is being removed or abstracted from the base. That particular acidic anhydride molecules now converted into the carbanion. Carbon is carrying the negative charge after the removal of one hydrogen atom by means of base. So, now that carbanion is now acting as nucleophile. Nucleophile. So, again coming to the point, nucleophilic addition reaction means now we have generated the nucleophile, that nucleophile should be added to the another molecules for the nucleophilic addition. So, this nucleophile now attack on the carbonyl carbon of the benzaldehyde. So, for attack the carbonyl carbon should have positive charge. How it is generated? Again the double bonded electron will be moved toward the oxygen. At that time this carbon become positive charge. At that time this carbon will be attacking on that particular positive charge carbon and we are getting this product. You can see over there. Now, you have a question, that this oxygen should be negative charge here. Actually, it was negative charge, but hydrogen coming from the you can say which is hydrogen plus is present in the reaction mixture, which is again coming to that negative charge oxygen, this oxygen, and we are getting hydroxyline. In the next step, you can see dehydration occur, one molecule of the water will be removed, which moiety should be removed, that OH, and this hydrogen will be removed. How? There is a introduction of a double bond in between this carbon and this particular OH and H is removed as H2O. So, there is a formation of double bond you can see here, and then after we are going for the hydrolysis of anhydride. Hydrolysis of anhydride, after that you can see here this bond is broken, hydrolysis occur and we are getting cinnamic acid as a product along with the acetic acid. So, very important reaction, very important reaction in which we are getting alpha beta unsaturated acid and the acetic acid. Now, coming to the use of Perkin condensation reaction. So, 3-polyfluoroalkyl cinnamic acid is being very useful building blocks have been obtained by the means of Perkin reaction, as you have seen. Then cinnamic acid is also a product of Perkin reaction, is very useful as antimicrobial and antioxidant molecules. Cinnamic acid is also used to prepare ethyl, methyl and benzyl ester, which is very useful in perfumery study industry, okay, because they are carrying very good smell. Again very important is one notable application for the Perkin reaction is the laboratory synthesis of the phytoestrogenic stilbene resveratrol, okay, very important molecules. So, this is all about the you can say Benzoin condensation reaction and the Perkin condensation reaction. I hope you have enjoyed the lecture, students. So, thank you so much. We will meet in the coming lecture with some another topics on the same unit. So, thank you, students. Thank you so much.